Greetings and welcome, friends. Mr. Waddy here. We are taking a look at our second assignment from 6.3. We're on page 310-ish, somewhere around there. But either way, we're on question 31. It said, graph the function and describe the domain and range. And it recommends, hey, in case you're stumped, check out example 5. So I just gave my students this graph here. And this graph happens to be, I wish it came out in color. I should, maybe next year I'll do that. This is the graph y equals 3 to the x. All right, so this is the parent function. And if I find some points on that, it crosses at 1. And then at -1, it's actually a third high. This is 1/3 unit high. At +1, it's going to cross at 3, which is directly related to the 3 there, right? 3 to the first, or like so. And at 2, what is 3 squared? 3 to the second is 3 squared means 3 times 3, which notice is 9. Right? No worries. So with this information, I noticed that this was a -1. And actually, let's just label what we've got. A is equal to 1. There's an invisible 1 being multiplied by this. The base of the exponent was 3, so that's why it was an uphill sort of situation. H, there is no H, right? -0 up there, so H is 0. And K is the -1. All right, where I'm getting this idea is from y equals a times b to the x minus h, and then plus k back down at the lower level. All right, yeah. So that's a little weird. So this -1, what this tells me to do is it's a vertical shift down 1. Down 1. Okay? So that's what's happening. So graphically speaking, let's move some of these points down 1 unit. So this point right here, my y-intercept, was at 1. Whoa. But now when I move it down 1, it's going to be at 0. This point was at 3, but now when I move it down 1, it's going to be at 2. This point was at 9, but now when I move it down 1, it's going to be at 8. And this point was at a third. And when I move it down 1, down a third, down 2/3, down 3/3, it's going to be down at, this is -2/3 high. Now, the other thing about vertical shifts is that's going to change where our asymptote was. All right? And some of my listeners won't be familiar with what that is, but the asymptote is the line that my curve gets infinitely close to, or infinitesimally small as it approaches, right? The difference between those, the line and the curve, but never gets there. And so the asymptote also got shifted down 1. So I'm going to draw a new asymptote for my new graph, just because that's going to make it a little easier for me to draw. So I'm going to start infinitely close to that curve, that line rather. Oh, that was a bad one. Here we go. And it gets steeper and steeper. And like so. Something to that effect. Right? And I'm not as interested in your ability to draw a super smooth curve as I am in your ability to understand where these points were translated and being able to go from there. So yeah, I'll also point out the asymptote was shifted down 1. And since our asymptote doesn't land on the x-axis, I think it's a great idea to draw that dotted line. It'll help you out just a little bit. Okay, so what we were working on was this idea of transforming and translating from our parent functions. Okay, so here we go. I've got a, in this case, is -1. All right. The base was 1/2. All right, the 1/2, the thing that was being raised to the exponent. The h, this one's going to be tricky. What do you guys think the h is going to be? Oh, with the save, it's the opposite of that number. And the k is whatever the number is there, so that's -3. Okay, and the graph that I am presently seeing is y equals 1/2 to the x. And we're actually going to graph this with two separate transformations. The first thing I'm going to do is this multiplying by -1. It won't stretch it or smoosh it, but it will reflect it over the x-axis. All right, so let's find some points and we'll reflect them. So right here, okay, no, oh, good catch. Notice my scale is different. All right, notice my scales are different. So that's one of the weird things about graphing exponentials. Being able to get your grid in the right place actually takes a lot of work. Beep, beep, beep. All right, so right here, it crossed at 1. And now it's going to be reflected to -1. Well, I'll do the reflections in a minute. Let's see. When it was equal to, when I plug in -1, it was 2 units high. All right, these grid marks are counting by 2s. All right, because I see the 10 there, and I had 5. Let's see. At -2, this was actually 4 units high, and at -3, this was 8 units high. And now, because this base was a half, when I do 1/2 to the first, this was actually half a unit high, and then it's like a quarter of a unit high, and then like an eighth of a unit high. But I'm not worried as much about those points. So let me draw my my blue graph, the one where I'm just doing y equals negative of 1/2 to the x. So this is going to be my blue graph after the reflection, and then I'll translate the blue graph. All right, are we cool with that? I'm going to draw stages, I guess, so to speak. Let's see. So this +8 is now going to be reflected all the way down to -8. This +4 is going to be reflected down to the -4. This +2 is going to be reflected down to the -2. This +1 is now at the -1, and then -0.5, -1/4, and -1/8. There we go. And so our blue graph looks something like this. Something like. All right, close enough. But now I'm going to translate again. All right, I'm going to do a horizontal shift. Let's see, left 1 unit. Right, in the negative direction, that's the left. Right? And I already took care of the opposite thing when I defined what h was. And I'm going to then do a vertical shift down 3 units. Okay? So I think with translations, I think that we can do both of those at the same time. If you wanted to do the horizontal and then the vertical as 2 separate graphs, you could, but I don't think we need to. All right, so taking this point right here, I'm going to move it left 1 unit. Now, 1 unit is not according to the grid mark. It's 2 grids. Okay, so left 1. I'm going to go over here. Then it's going to go down 3, which in the vertical scale, the grid marks, the tick marks counted as 2. So I'm going to go down here. So that's at -11 high. So -4, -11 is where that point is. I'll even label it, but you don't have to label all your points. Okay, let's take this one. So I'm going to move it left 1 unit. All right, -2 to -3, and then down 3, which is going to be 1.5 grid spaces, because my grid spaces were based on 2 units. Yeah, yeah. All right, let's do it again. Here we go. Left 1 unit and down 1.5 grid spaces. All right, left 1 unit, and then down 1.5 grid spaces. Well, my horizontal axis, yeah, the grid spaces count as a half, right? So yeah, so make sure you're paying attention to your scale here. Let's left 1 unit. Oh, and then this is really tricky. So this is at like a 1/4 grid space. So if I go down 1, I think I'm landing about here. 1.5 should be up a 1/4 from that. But either way, let's actually figure out where our asymptote is. Our asymptote is also being shifted down 3 units. Right, also shifted down 3 units. Well, the asymptote is going to be a horizontal line, which you guys don't have to know this, but it will end up being y equals -3 is the equation of that horizontal line. So let me draw that horizontal line. Right, something like that. And then I can draw the giraffe. Ish. Bam. Close enough for me. All right, but that's the idea. So I did this through 2 separate transformations, and I was able to reflect it and shift it left and down. It is also possible that I could have, in addition to a reflection, it could have stretched it or smooshed it. There's all sorts of different things that happen, but the idea is you interpret kind of what's going on based on the A, B, H, and K. All right, last problem, because yeah, I got to pick up the pace here. All right, we're 11 minutes in. That one I just went over is gold right there. All right, it says compare the graphs and find the value of H, K, or A. All right, so let's take a look at the original graph. We'll find some points on it. So the original one was here, and here, and here, and here, right, for some of those points. Notice my scale. It's counting by 2s, but the grids are counting by 1s. Oh. I was looking at the wrong one. My bad. There we go. Let's look at the white graph here. The top one was y equals 2 to the x, or f of x equals 2 to the x. So yeah, that one crosses at 1, then it crosses at 2, then it crosses at 4, and it would cross again at 8. But I don't need to know that. So now the question is, when it went to the orange graph, 1 became a half. All right, I'll label these with green so they show up. 1 became a half. 2 became 1. 4 became 2. And 8 became 4. So what happened to all of those y values that shrunk them? By what factor were they shrank? Right, if 1 became a half, if 2 became 1, if 4 became 2, and 8 became 4, what's happening to all of those values? They're doing what? They're being divided by 2? Or I could view it as they're being multiplied by a half, right? Half of 1 is a half. Half of 2 is 1. Half of 4 is 2. And so the A value that goes in here must have been the half. All right, this was a vertical smoosh, all right, by a half. So my function, g of x, would have been 1/2 times 2 to the x. And I would have been able to say A equals 1/2. All right, so the idea is you would have had to pick some points and then figure out what happened to them and find out kind of were they shrunk, were they reflected, were they translated, and try to figure out A, H, or K. All right, well, thanks for watching, Internet friends. Have a good day.